Hello students, my name is Mrs. Meetali Risbud from Fergusson College Chemistry Department. In the previous sessions, we have discussed some concepts in the topic solution. Now in this session, we will discuss few more concepts and the problems in this topic. Let us move to PowerPoint presentation. One top observed that there are similarities between the properties of a gases and the properties of a solution, and he put forth his theory of solution. According to his theory, the solute molecules behave like gas molecules and move in random direction in the solution. On collision against semi-permeable membrane, the solute molecules exert osmotic pressure. The laws observed for the solutions are exactly similar to the gas laws. Last year, you have studied the different gas laws such as Boyle's law, Charles' law, then Avogadro's law, Gay-Lussac's law, etc. Osmotic pressure and the concentration of solution. Now, for dilute solution, pi is equal to N2RT upon V. Now, this relation is given in your book. But how this relation is obtained? एवढं तुमच्या बुकमध्ये दिलेलं आहे. हे रिलेशन कसं आलं हे माहिती नाही, दिलेलं नाहीये. So for this, you should know. According to the one-top Boyle's law, pi means osmotic pressure of a dilute solution is proportional to 1 upon V when the temperature is constant. According to the one-top Charles' law, pi is directly proportional to absolute temperature T at constant concentration. Now, if we combine these two laws, we can write pi is proportional to T upon V. Or we can write pi V is proportional to T. And therefore, we can say pi V is equal to some constant into T. Where this proportionality constant is the same as the gas constant R. Therefore, we can write pi V is equal to RT, where V is the volume of a solution that contains 1 mole of a dissolved solute. See here, what is V? V is the volume of a solution that contains 1 mole of a dissolved solute. If n moles of the dissolved solutes are present in V volumes of a solution, then this equation will become pi V is equal to nRT. So pi V is equal to nRT. Here n is the number of moles of a solute. In the previous session, I have told you the moles of a solute are denoted by N2, and that's why we have to write the expression as pi V is equal to N2RT, or which is same as pi is equal to N2RT upon V. So V is the volume of solution which is in liter, or we can say dm cube. N2 moles of a non-volatile solute. R is gas constant which is equal to 0.08205, or sometimes it may be 0.0821. कधी ही व्हॅल्यू दिलेली असते किंवा प्रॉब्लेम्स मध्ये कधी 0.08205 च्या ऐवजी 0.0821 ही पण व्हॅल्यू देतात. Liter or dm cube, atmosphere per degree per mole. Of course, R can be expressed in joule. Pi is the osmotic pressure in atmosphere, and N2 upon V. What is N2 upon V? What is N2? N2 is moles of a solute. What is V? V is the volume of a solution in liter or dm cube. So N2 upon V is what? It is nothing but moles per dm cube, or we can say moles per liter. Moles per liter means what? It is the molarity M. So pi is equal to, instead of this we can write M. So pi is equal to mRT. So N2 upon V is what? M. So mRT, pi is equal to mRT. Next part is the molar mass of a solute and osmotic pressure. Our relation pi is equal to N2 RT upon V. What is N2? N2 is number of moles of a solute. Number of moles of a solute means what? Mass of a solute divided by molar mass of a solute. That is W2 upon M2. So pi is equal to W2 RT as it is divided by M2 into V. Let us write the expression in terms of M2. So M2 is equal to W2 RT, this terms as it is divided by pi V. So what is the relation between the molar mass of a solute and osmotic pressure? The relation is M2 is equal to W2 RT divided by pi V. Now, if only relation is asked, you have to write this. If the derivation, then in short, you have to write all the parts starting from the beginning. You have to write like this, then the meaning of the different terms. So, we have discussed so far, we have discussed 4 colligative properties and one more thing which is important according to the exam point of view, that is the relation between the molar mass of a solute and the colligative property. प्रत्येक colligative property आणि molar mass of a solute हे आपण रिलेशन हे डेरिवेशन बघितलेलं आहे. ही डेरिवेशन्स 2 मार्काला परीक्षेला विचारतात. Now next point is the reverse osmosis. The direction of the osmosis can be reversed by applying a pressure larger than the osmotic pressure. The pure solvent then flows from solution into pure solvent through semi-permeable membrane. Osmosis मध्ये काय होतं? The flow of a solvent into the solution through a semi-permeable membrane. आता इथं काय आहे? Reverse osmosis, direction of the osmosis is reverse if we apply a pressure larger than the osmotic pressure. So the solvent molecules from the solution मधले solvent molecules कुठे येतात? सेमी परमिएबल मेम्ब्रेन मधून पास होतात. कशामध्ये? सॉल्व्हेंट मध्ये. So the pure solvent molecule then flows from a solution into a pure solvent through semi-permeable membrane. So diagrammatically we can see here the salt water and this is the fresh water separated by this semi-permeable membrane. Pressure greater than osmotic pressure is applied on this solution side. What happens? Pressure more than or the larger than osmotic pressure is applied. What happens? The direction of the osmosis can be reversed. So the direction is reversed due to the application of the force. आणि मग काय होणार आहे याच्यामुळे? Application of a pressure, the direction of the osmosis is reversed. मग काय होणार ह्यामुळे? The pure solvent molecules from a solution passes through the semi-permeable membrane into the pure solvent. And this fresh water is taken out. Have you followed this reverse osmosis? Now, colligative properties of electrolyte. So far, we have discussed the colligative properties of a non-electrolyte solute, isn't it? Non-volatile and non-electrolyte solute. And we have also discussed the relation between the molar mass of a solute and the colligative property. And we have discussed that the molar mass of a solute can be determined by measuring the colligative property. Now, each colligative property is related to the molar mass of a solute. It is possible to determine the molar mass of a non-volatile, non-electrolyte solutes from dilute solutions. In case of a solutions of the electrolyte, it is observed that the observed colligative properties are higher than theoretically expected value of colligative property shown by the solution of non-electrolyte of the same concentration. See here, what is an electrolyte? Electrolyte is a substance which dissociates into ion. We have already discussed that what is the meaning of the word colligative property? Colligative properties are the properties of a solution which depends on the number of solute particles present in the solution and not on their nature. Electrolyte is a substance which dissociates into ion. So if we consider a solution of the electrolyte as it undergo dissociation, ions are produced. Colligative property depends on directly proportional to the number of particles. Particles may be atom ions or a molecule. So here, as the ions are produced, as the number of ions are increases, then the colligative properties are also increases. So we can say that in case of a solutions of the electrolyte, it is observed that the observed colligative properties are higher. Why higher? Ions are increases, number of ions are increases, higher than the theoretically expected value of the colligative property shown by the solution of non-electrolyte of the same concentration. The electrolyte undergo dissociation. This you have to remember. The molar masses of the electrolytes in aqueous solutions determined by the colligative properties are found to be considerably lower than the formula masses. Now see here, molar masses of the electrolytes in aqueous solutions is determined by the colligative properties are found to be lower than the formula masses. Observed lower molar masses of the electrolyte solutes are due to the dissociation of the solute molecules. Now, when we have discussed the relation between colligative property and molar mass of a solute, there we have seen that colligative property is inversely proportional to the molar mass of a solute, or molar mass of a solute is inversely proportional to the colligative property. Colligative property वाढली की molar mass कमी होणार, and colligative properties are directly proportional to the number of a solute particles. इलेक्ट्रोलाइट आहे, अंडरगो डिसोसिएशन, आयन्स प्रोड्यूस होतात, कॉलिगेटिव्ह प्रॉपर्टी इन्क्रीज होते, अँड दॅट्स वाय द मोलेक्युलर मास कसं असणार आहे, डिक्रीज होणार आहे. सो द लोअर, दॅट्स वाय द मोलर masses of the electrolyte in aqueous solutions determined by the colligative properties are found to be considerably lower than the formula masses. Due to what? Due to the dissociation of the solute molecules. We have completed all the theory part. Now let us discuss the problems. First problem, the Henry's law constant of methyl bromide is 0.159 mole per liter per bar at 25 degrees Celsius. What is the solubility of methyl bromide in water at 25 degrees Celsius and at a pressure of 130 mmHg? Now remember that when the problem is asked, you have to solve the problems in 4 steps. First step is write the given things and write the things which you have to find. Then find out the formula which relates the given things and the things which you have to find. So writing of correct formula is the first step. Second step is correct value substitution. Substitution करायचं correct value चं. Third step is the log calculations, and the fourth step is the correct answer along with correct unit. Unit लिहायचं, नुसतं answer ची value लिहायची नाही. Unit नसले की अर्धा मार्क जातो. Now let us see here our problem according to the Henry's law. First step, S is equal to KH into P. KH is equal to दिलेले value 0.159 mole per liter per bar. P is 130 mmHg. So which formula? S is equal to KH into P. बरोबर आहे? KH दिलेले आहे, P दिलेले आहे. मग डायरेक्ट सबस्टिट्यूट करायचं का? So S is equal to KH. हे KH आहे, ही P ची व्हॅल्यू आहे. No, remember that KH is 0.159 mole per liter per bar. आणि आपण हेनरी लॉ जेव्हा केला होता, हेनरीज लॉ, तेव्हा आपण बघितलं होतं S is solubility which is in terms of mole per liter and P is the pressure which is in bar. Given pressure is in mmHg. So our first step is to convert this mmHg into bar. How to convert it? we know that 1 atmosphere is equal to 760 mmHg. So convert this 130 mmHg into atmosphere. So if 1 atmosphere is equal to 760 mmHg, 130 mmHg is equal to how many atmosphere? Cross multiplication. That is equal to 130 upon 760 atmosphere. Now, 1 atmosphere is equal to 1.01325 bar. 1 atmosphere is this many bar. हे रिलेशन माहिती पाहिजे. आता आपले atmosphere किती आहे? 130 upon 760 atmosphere is equal to how many bar? Again cross multiplication. So it is equal to 1.01325 into 130 divided by 760. So this is a pressure in bar. And if we calculate this, हे calculate केलं की आपलं उत्तर येतं 0.1733 bar. So this is a pressure in bar. This is the KH. So we know now KH and we know pressure. So let us substitute the value of KH and P in this expression so that we can write S is equal to 0.159 mole per liter per bar into this pressure 0.1733 bar. See here, this bar per bar will get cancelled, and which units will be left? Mole per liter. And if we do the multiplication, we'll get the answer as 0.2755 mole per liter. So finally you have to write solubility of methyl bromide in water is this answer. Unit is important. Unit nahi lile ki ardha mark janar. Now next problem is the vapor pressure of water at 20 degrees Celsius is 17 mmHg. What is the vapor pressure of a solution containing 2.8 gram urea in 50 gram of water? So what is given? Mass of solute, urea is here, solute is given. How much it is? 2.8 gram. Then what is M2? M2 is number 2 म्हणजे solute. M म्हणजे molar mass. Molar mass of a solute. Solute is urea. Molar mass of a urea 60 gram per mole. W1 mass of a solvent तिथे दिलेलं आहे 50 gram of water, so 50 gram. M1 molar mass of a water, formula is H2O, so 18 gram per mole. And what else is given? The vapor pressure of a water 17 mmHg. Water is a solvent, so the vapor pressure of a pure solvent P1 naught is given. So P1 naught is equal to 17 mmHg. So which formula you have to use? P1 naught minus P1 upon P1 naught is equal to N2 upon N1. N2, number of moles of a solute, that is W2 upon M2. And N1 is W1 upon M1. So that we can write W2 M1 divided by W1 M2. So let us substitute all the values. P1 naught is 17 mmHg. So 17 mmHg minus P1, we have to find P1. Why? What we have to find here? What is the vapor pressure of a solution? P1 is the vapor pressure of a solution. So you have to find P1. P1 naught minus P1 upon P1 naught. P1 naught is 17 mmHg. P1 you have to find. So minus P1 as it is. P1 naught again 17 mmHg. N2. N2 is N2 upon N1, which is equal to W2 M1 upon W1 M2. So W2 is 2.8 CW2. Then M1 is 18 divided by W1 is 50 and M2 is 60, isn't it? Now these calculations we can do it orally. The multiplication comes to be 3000. So 2.8 into 18, answer of this, it comes to be 50.4. See here the units are same, gram per mole. Actually it is a ratio, so no unit. Hey, answer येतो 50.4 upon 3000. And if we solve this, you will get the answer as 0.0168. So 17 mmHg minus P1 upon 17 mmHg is equal to 0.0168. So 17 mmHg minus P1, transfer this term to RHS. इथे ही term RHS ला transfer केली. So 0.0168 into 17 mmHg. ह्याचं मल्टिप्लिकेशन आलं 0.2856 mmHg and this terms as it is 17 mmHg minus P1 is equal to this thing. So P1 is equal to this निगेटिव्ह साइन आहे या साईडला ट्रान्सफर करायचं, या साईडला मीन्स राईट साईडला ट्रान्सफर करा लेफ्टचं आणि ही राईट साईडची टर्म ही लेफ्ट साईडला ट्रान्सफर करूया. So P1 is equal to 17 mmHg minus this 0.2856 mmHg. It comes to 16.71 mmHg. So final answer P1 is equal to 16.71 mmHg. What is asked? Asked what is the vapor pressure of a solution? So below this write therefore the vapor pressure of a solution P1 is equal to this thing. A solution of a citric acid formula is given C6H8O7 in 50 gram of acetic acid has a boiling point elevation of 1.76 Kelvin. If Kb for acetic acid is 3.07 K kilogram per mole, what is the molality of solution? Delta Tb is given, boiling point elevation. So what? Delta Tb is given. Kb for acetic acid is given. It is how much it is? 3.07 K kilogram per mole. And what is asked? What is asked? Molality. सोपा अतिशय प्रॉब्लेम हा 2 मार्काला विचारतील असा प्रॉब्लेम विचारला तर तो किंवा MCQ मध्ये सुद्धा मे बी विचारतील कारण अतिशय इझी आहे. सो डेल्टा टीबी इज इक्वल टू केबी इंटू एम. एम काढायचं आपल्याला. सो एम इज इक्वल टू डेल्टा टीबी अपॉन केबी. डेल्टा टीबी दिलेला आहे 1.76 केल्विन. कॅपिटल के हा कॅपिटल के आहे डिवायडेड बाय केबी इज 3.07 के किलोग्राम पर मोल. हे दोन्ही कट होणार हा के आणि हा के आणि एम इज इक्वल टू पॉइंट. हे जर सॉल्व केलं तर इथे येणार 0.5732 युनिट्स. किलोग्राम इथे आहे सो पर किलोग्राम येणार आणि पर मोलचं मोल होणार न्यूमरेटरला गेल्यानंतर. सो एम इज इक्वल टू 0.5732 mole per kilogram. So the molality is equal to 0.5732. This answer you have to write. At 298 Kelvin, 1000 here also this K should be capital K आहे तो 1000 centimeter cube of a solution containing 4.34 gram of solute shows osmotic pressure of 2.55 atmosphere. What is the molar mass of a solute? Value of R is given. जसं मी मगाशी सांगितलं होतं इथे व्हॅल्यू आली आहे. R ची व्हॅल्यू दिलेली आहे 0.0821 liter atmosphere per degree per mole. Now solution. Volume is 1000 centimeter cube that is equal to 1000 ml. म्हणजे लिटर किती? 1 liter. So V is 1 liter. W2 mass of a solute किती आहे? 4.32. पाय ची व्हॅल्यू किती दिली आहे? पाय इज 2.55 atmosphere. So which formula you have to use? Pi is equal to N2 RT upon V, which is same as W2 RT upon M2V. What you have to find? What is asked? Molar mass of a solute. So let us write the formula in terms of the molar mass of a solute. So M2 is equal to W2 RT upon pi V. So M2 is equal to W2. W2 is how much? 4.34 gram. Next problem. At 298 Kelvin, 1000 centimeter cube of a solution containing 4.34 gram of solute shows osmotic pressure of 2.55 atmosphere. What is the molar mass of a solute? Value of R is given as 0.0821 liter atmosphere per degree per mole. So what is given? Volume is given. Given volume is in centimeter cube. So 1000 centimeter cube. cc, centimeter cube म्हणजे cc, which is as good as ml. So 1000 ml. So how much liter? 1 liter. W2 is mass of a solute. How much it is? 4.34 gram. Pi. Osmotic pressure. How much it is? 2.55 atmosphere. Which formula we have to use? We know the formula. Pi is equal to N2 RT upon V, which is same as W2 RT upon M2V. So M2 is equal to W2 RT upon pi V. So M2 is equal to W2. W2 किती आहे? 4.34 gram. R R ची व्हॅल्यू गिव्हन ही आहे ती 0.0821 लिटर ॲटमॉस्फिअर पर डिग्री पर मोल इंटू T टेम्परेचर किती आहे टेम्परेचर 298 डिवायडेड बाय पाय इज 2.55 इंटू V इज 1 लिटर. So M2 is equal to, substitute केलं आपण, units liter and this liter will get cancelled. Atmosphere and atmosphere will get cancelled. Per degree and Kelvin म्हणजे per Kelvin आणि Kelvin हे कॅन्सल होतील. कुठली युनिट्स राहणार ग्रॅम आणि हे पर मोल. सो M2 is equal to हे सॉल्व केलं की आन्सर येतं. आन्सर इज 41.65 gram per mole. Now what you have to find? The molar mass. We know that the molar mass of what? Molar mass of solute म्हणजे M2 पाहिजे आपल्याला. So M2 is equal to आणि मोलर मास असल्यामुळे युनिट काय असणार त्याचं ग्रॅम पर मोल. Hello students, in this session we have discussed the relation between molar mass of a solute and osmotic pressure. We have discussed the colligative properties of the electrolyte and we have discussed the problems. Some problems are solved one and some are unsolved. In this way, we have covered entire topic solution. So thank you and I wish all of you all the best for your board exam.